Hello, I am Shravunti Costa, student ID 2354453 from the Department of CSC. In this video, I will explain my assignment for the course Digital Logic Circuit, which is a digital parking control system. So to begin with, I created a block diagram and flow diagram that shows how the system works. At the entrance and exit of the parking garage, I placed sensors that detect the arrival and departure of cars. These sensors send signal to a counter circuit which keeps track of the number and cars inside the garage. Based on the count, the system controls two 7-segment display. One shows full when the garage at its maximum capacity and other is shows space available and blink when there is room. Based on the counter, the system controls two 7-segment displays. One shows full when the garage is at maximum capacity, the other shows space available and blink when there is room. This flow ensures a logical and automated design making process. So next, I designed a synchronous counter using GK flip-flops. Since the maximum number of cars is 8, so there have a confusion among 3-bit and 4-bit counter. So the max value of the 3-bit counter is 0 from 7 and the 4-bit counter is 0 from 15. So that's why I used 4-bit counter instead of 3-bit counter for the better result. So the best representation for maximum 8 counters are a 4-bit synchronous up-down counter. The counter increases when a car enters and decreases when one exits. I showed the internal connection of GK flip-flops when each flip-flop captures input at the rising clock edge. The counter ensures accurate car tracking of all times. Now for the display control, I used 555 timer circuit. The first timer shows full continuously using an stable configuration. The second timer makes space available blink using a monostable configuration. Let me explain the calculation. From my ID, the value of P is 40 and the duty cycle is 60%. Also the frequency is 8 Hz. I selected resistors and capacitor values to meet the duty cycle. From the option given, I used 250 microfarad capacitor to tune the output frequency and blinking time. To control the blinking behavior, I created a finite state machine which is FSM. The FSM output A for TH MS and B for TL MH. Since both TH and TL are over 4, I said both of 4 milliseconds are instructed. I drew the state diagram and state table and wrote the Verilog HDL code to alternate between outputs A and B. This FSM works with a 1 microsecond clock, ensuring accurate timing control. And the last but least step is limitation and future improvement. Finally, the system has some limitations. The car count is fixed at 8. To support more cars, we would need more flip-flops and modify the counter logic. The 555 timer lacks an enable pin, so we can't easily control it externally. To improve, all can replace 555 timer with a microcontroller, which would allow more flexible control and dynamic display handling.